Hello guys, welcome back to another problem solution video. Today we get another question here from the GAUSS quiz, and as always, let's first start off by reading the question. So, in quadrilateral PQR and S, diagonals PR and SQ intersect at O. Inside PQRS, SP equals SQ equals SO, which is going to be equal to 1, and QSR is going to equal to double of angle QSP. Now, mark determines the measure of the 12 angles that are the interior angles of triangle POS, triangle POQ, triangle ROS, and triangle ROQ, and the measure of each of these angles in degrees is a positive integer. Exactly 6 of these integers are prime numbers. So how many different quadrilaterals have these properties that are not rotations or translations of each other? Now, let's first look at what we've been given here. Now, we can see that we have SP is going to be equal to SQ, or is going to be equal to SR, is going to be equal to 1. Now, we don't actually need this value 1 since we're just calculating the angles, so we'll just write it like an equal sign. So as you can see here, SP, SQ, and SR are all equal as indicated by this line here. Now, let's first write off some of the things that we have here. Now, we can see that angle QSR is going to be double of QSP. So I'm going to write QSR going to be equal to 4x, and PSQ is going to be equal to 2x. Now, because we have this, we can now further solve for the other angles. Now, as you can see here, we're able to see that we have some isosceles triangles here, and this is going to be really useful as this means that we can solve for more angles. Now, this means so since we have this is going to be equal to 6x, we can tell that since 180 is going to be equal to, as you can see here, let's just label SPR here. So we're solving this angle. Let's label SPR as y for now. Now, since this triangle here is going to be an isosceles triangle, as these two sides are equal to each other, we can see that 6x plus y down here is going to be equal to 180. So 180 is going to be equal to 6x plus 2y. Now, this means that y, or SPR slash SOP, is going to be equal to, we can solve in terms of x, is going to be equal to 90 minus 3x. Now, because we have this here, we can now solve for the other angles of this triangle. So let's first look at SQP as well here. Now we can see that I'll actually just write this down here. So 90 minus 3x. Now let's look at SQP and SPQ. Now if we look at the bigger triangle here, so SQP, there are also going to be two sides that are equal to each other. So this is also going to be an isosceles triangle. Now, since this is an isosceles triangle, this means that angle P and angle Q here are going to have they're going to be equal to each other. And this means that 180 is going to be equal to 2x plus we'll put another buffer variable here. Let's just say 2z, and this means that z here is going to have to be equal to 90 minus x. So we can see here this is going to be 90 minus x, and this here. So in total, this big angle here is 90 minus x, but this smaller angle here is 90 minus 3x, which in this part here is going to be 2x. And also write 90 minus 3x down here as well. So as you can see here, by using the isosceles triangles, we can now sort of simplify and solve for each of these angles separately. So now let's solve for the rest of the angles. Now, as you can see here, we have some pretty simple things here. So this is 90 minus x. This is 2x. So this here is going to have to be equal to 90 minus x. This here, since we have 2x here and 90 minus 3x, this has to be 90 plus x. So it has to be similar logic but before, so it has to be 90 minus x. And here is where it gets a little interesting. Now, although it's still pretty simple from before, as you can see here, there's just a bigger isosceles triangle, and we have a 4x here. So in other words, this will be 180 minus 4x divided by 2. So here is going to be 90 minus 2x. 90 minus 2 theta, 2x. Here's going to be 90 plus x. And down here is just going to be x. Why? Well, because this bigger angle is 90 minus 2x, the smaller part is 90 minus 3x, so here is obviously going to be x. Now, obviously, this is really messy, so now we're just going to write out each of the angles separately. So just don't worry about this graph anymore, we'll just write them down algebraically. So we see that angle QSP is going to be equal to angle RPQ, and these two angles are going to be equal to 2x. Now we're just going to be doing this with literally all the other angles here. So angle QSR is going to be equal to 4x. Angle SOQ, SOP, and is going to be equal to angle RPS, which is going to be equal to 90 degrees minus 3x. Then we have QRP, which is going to be equal to x. We're going to have RQX here. RQS is going to be equal to 90 minus 2x. Angle SQP is going to be equal to angle POQ, which is also going to be equal to angle RRS. It's going to be equal to 90 minus minus x. And finally, we have angle POS, which is going to be equal to angle QOR, which is going to be equal to 90 plus x. So now here we have a total of 12 different angles, and we have a total of 1, 2, 3, 4, 5, 6, 7 different possible values for them. Now we need to go through all of these angles and their degrees, see which ones cannot absolutely not be prime. So let's first look at 4x here. Now 4x obviously can't be prime. No matter what number x is, this cannot be. No matter what integer x is, this physically cannot be prime. Which is why QSR is not going to be a prime. So we just don't need to worry about this one. Now let's look at QSP. QSP/RPQ. Now this one also cannot be prime. And why is this? Well, this also goes for SOP and QRS. And the main reason behind this is because the only way for these numbers to actually be prime is if x is going to be equal to 1. Although there's just a really big problem here. If x is going to be equal to 1 here, it'll be pretty easy to see that we actually don't have enough primes, and the number of primes that we do have in these 12 angles is not going to be exactly equal to 6. So this means that 2x here is not possible, and 2x here is not possible, and 90 minus 3x is also not possible. Finally, we're going to be looking at some of the other ones. So RQS, SQP, POS, and their respective equal angles. Now, as you can see here, 90 minus 2x is also just going to be not possible, as no matter what x is, this is always going to be an even number. And even numbers that aren't equal to 2 obviously can't be prime, and like before, if you plug in x is going to equal to 44, this also just doesn't work. So this means that 90 minus 2x also doesn't work. So now that we've eliminated these 4, we can just cross them out here. I crossed out the wrong one, sorry. So as you can see here, we have 3 left. So we have QAP, SQP, POQ, and ROS, and POS and angle QOR. So in other words, our 3 values, x, 90 minus x, and 90 plus x, have to be prime. And this obviously works out as we have 1x, 3 90 minus x's, and 2 90 plus x's. So 1 plus 3 plus 2 equal to 6. So this means that all 3 of these have to be a prime integer. However, there's also something else that we need to look at, look out for. So going back to our graph here, let's look at S, P, and R. Now we can see that angle S here is going to be equal to 2x plus 4x, which means that, so I'll write this down here, angle PSR, or just angle S, is going to be equal to 6x, and this has to be smaller than 180 degrees. And this means that x has to be smaller than 30 degrees. And so now what we need to do is that we need to now plug in every singular prime number below x, or below 30. So this would be numbers like 2, 3, 5, 7, 11, 17, 19, 23, and 29. And now we just need to plug in all these numbers are equal to x and see if 90 minus x and 90 plus x are also going to be prime. Now here, we can see that we can, now sadly, 2, 3, 5, I forgot 13 in here, 13, and 13 cannot be possible. If you plug these into x, these just won't work, which means that x has to be equal to our remaining prime numbers, 7, 11, 17, 19, and 23, and 29. So in other words, we just looked at every single prime number that's below 30, and then we plugged those into x and saw that which ones received that x, 90 minus x, and 90 plus x were all prime, and these numbers were 7, 11, 17, 19, 23, and 29. And so there's 1, 2, 3, 4, 5, 6 of them. So the answer to this problem should be D, which is equal to 6. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.